All right, everybody, welcome to another OpenShift Commons briefing. Today, as I like to do on Mondays, we have new topics, new initiatives, upstream projects, and today we've brought with us Ben Breard from the RHEL team, and he's going to talk about the operating system on the edge. Edge is pretty new and pretty edgy, but Ben brings a lot of experience to that, so even though he's expired, we will really enjoy this talk. So Ben, take it away, and at the end of his presentation, we'll have live Q&A.
Awesome. Thanks, Diana. Hey, so my name is Ben Breard. On the product management team here at Red Hat. I've basically spent the past 5 years kind of operating in between RHEL and OpenShift, kind of covering all of our immutable operating systems, container runtimes, image offerings, and things in that kind of that world. And now really focused on Edge and what it takes to be successful there. Yeah, so I just hit 10 years at Red Hat, so it's awesome. I have the greatest job in the world. I get to play with all the fun stuff and work with all these super cool use cases from customers. So it's absolutely great. And yes, I at one time had an RHCA. One day in the future, I hope to update that, but we'll see how this goes. Okay, so what is Edge? Well, for everyone's education, oh, that's terrible. Yeah. Anyway, we'll keep moving here. Basically, we now have the situation where we have sources of data all over the place, and there's all kinds of use cases to capitalize on this data quicker, faster, more efficiently. And in some cases, we've reached the limits of where we can actually ship data to a cloud or data center environment to process this. And so putting compute closer to these sources of data, sometimes those sources could be humans, sometimes it's sensors, it can be all types of use cases, but that's typically the combination of what we're talking with Edge. And so, of course, you guys can probably imagine all of the things that we take for granted inside of a data center or cloud environment are now luxuries from an infrastructure side that may or may not exist at the edge. So that's kind of a key thing. And another point I would make is depending on what industry you're in, edge is going to look completely different. Sometimes it will kind of look and feel like a remote office, maybe. It's totally different for telcos and content providers and so forth. In the industrial and manufacturing space, it looks quite different as well. So every industry kind of has its own take, and so it's good for us to look at this from a holistic view, not really just from one industry, and realize that it does vary quite a bit. If we step back and kind of look at common challenges here, we do see that scale is often associated with these. In a data center, pretty common for us to look at the tens of thousands, approaching hundreds of thousands types of deployments. In Edge, though, it's often that these numbers start in the millions range, and you can just imagine trying to perform a task on a million devices. We start hitting like limits of what you can do with protocols and things of that nature. And so we have to look at the scale problem very differently in this world. In terms of just interoperability, I think right now we're kind of seeing the West is kind of the Edge is kind of like the Wild West in a lot of ways, in terms of just what hardware is available, what accelerators are being used, if any. Oftentimes there's kind of a existing legacy footprint and how newer systems are interacting with that, or maybe they're interacting with like hardware systems talking to PLCs on a manufacturing line that they can't stop for safety protocols. And there's it's a lot of moving pieces that's going to continue evolving and adapting a lot over the next few years. But how these protocols work at a very low level, sticking with the manufacturing case, is there's not a lot of commonality between the vendors and types of communication that we see at a very low level. So it's a complicated matrix of layers of technology that that intersect here. And of course, from a consistency perspective, uh, basically keeping things updated. We oftentimes talk about the convergence of operational technology with IT networks and systems. And that right there creates sometimes organizational tension, but also creates huge opportunity for us to solve problems and really work with customers to make sure that we can meet basically requirements and have these systems kind of converge over time. All right. And when we look at kind of an application lens here, you guys are going to see that all the traditional cloud native and a lot of the AI ML stuff. This slide should really say OpenShift and RHEL on it, because these are really the types of applications that we see being super relevant in the edge space. There's already a lot of like traditional footprint out here. Like I said, RHEL specifically has been doing edge computing long before we had that word or that label as an industry. And so there's already a sizable footprint out there for that. We do see most of the growth happening on the cloud native side. Could just be repackaging of existing applications, as well as literally forklifting workloads from other environments and putting those out at the edge. And then, of course, the AI/ML side is obviously growing really, really fast. And whether you're training models or just executing them, close to sensors, for example, or doing inferencing on, say, like a webcam or these types of things, we basically see the OS as being, or RHEL specifically, being a great fit for a lot of these use cases. All right, so I'm going to put this in context, and we've got a lot of cool deployments for OpenShift in an edge context. We can now do smaller 3-node clusters. The remote workers landed in 4.6, or much more progress has been made there. And then the single node work is coming, is on the way. But today, just to put this in context, we're talking about just like, what can I do with Linux? And so you could think of this, I've had 2 people come up with this term. We have K8s, and there's kind of K3, which is like the slimmed down Kubernetes. Kind of think a lot of this is like K0, right? Like, what can I do with container runtimes and the OS? And it turns out you can actually do a heck of a lot here. And so just again, kind of going back to the trends that we see happening, a lot of times you'll see edge computing connected somehow with some type of digital transformation type of initiative. It could be, the IT OT convergence is another huge thing going on, or really people just trying to make better use of analytics on top of data. To either make them smarter from a competitive standpoint, improve customer experience, or really just increase like operational efficiency. All of these are kind of tend to be the bigger trends that people are going after. I talked a little bit about the verticals already, so I'm not going to rehash that. But what can you do with kind of a standalone OS? At this point, really just a container host where the concept of a cluster actually doesn't add value. And so these like independent systems that just once you put them in motion, keep going. That's a really common use case here that we can solve really well, particularly on smaller footprint devices, either just edge servers or a gateway to where we're really just passing packets back and forth. Talked a little bit about computer vision a second ago, where we're doing inferencing on like a feed of what's coming into the system and trying to identify what's happening on it and make decisions from that. Kiosks are still a huge thing, particularly for like in the transportation space. That's still, we see huge investment happening there. And then of course we see the classic kind of IoT use case rolling up under edge as well. All right, so with RHEL in the next update, which will be 8.3, we are on a time-based model now. So the November release, we kind of have these 4 things landing, which represents, our first step in the journey of kind of adapting RHEL for edge. We're not finished with this release. This represents kind of that first step for us. And effectively what we have is this tool called Image Builder, and we'll go over this in more detail. But basically, we can generate these pretty small footprint operating system images. They can either be purpose built for a particular piece of hardware, use case, workload, or kind of a generic container host. And then we get a whole bunch of benefits because we're using RPM OS tree in the background, which makes it super easy to update, super easy to be really efficient with those updates over the wire. And then we have some cool technology that will help us roll back if we need to. And we'll take a look at those in more detail. But before we get into kind of some demos and some other things, I want to kind of talk a little bit about running containers with traditional workloads. I mentioned earlier that there's pretty sizable legacy footprint in a lot of these edge use cases. And I want to, basically there's no technical reason why we can't just drop in containers next to traditional daemons running on a Linux system. It works great. Now, depending if you need to orchestrate and do fancy things with those containers, you will probably hit the limits of that pretty quick. And that's obviously where Kubernetes has a massive amount of value. But if this is more of a static workload type case, this is pretty simple to do and works really, really well. Again, one of the things I do want to point out is that in RHEL 8, we make it easy for just regular daemons running on the system to really present the same kernel primitives that give you container isolation to services installed on your system. So it's something I find in talking with people that a lot of people don't know, that we can easily add all kinds of namespaces. I'm trying to like seccomp. These types of things are really easy, and there's really a list of like kind of like 8 line items you can put into a unit file that starts an app, and it will just basically give you that very, very similar type of isolation, which is super cool when you consider kind of how connectivity is increasing and how important security is and will continue to be in the future. Okay, so we are, from a container runtime perspective, we are talking more about the Podman side of the house right now. Hopefully everybody here is kind of familiar with the differences of CRYO, which is meant to talk to the Kubernetes CRI, and Podman, which uses basically all the same underlying components, but it's kind of standalone in terms of it has a CLI, now has a Docker compatible API in this version that's going to come out in 8.3. And just super lightweight runtime, and works incredibly well. One thing we like about it for this use case is we have much better integration with Podman and systemd than we ever had in the Docker world. And so, again, this makes it super easy to just, if you, again, going back to kind of that static workload model, have container images that can auto restart. The system knows how to run these just like any other service. So Podman is really great for that. So again, we got the new API coming in 8.3, and then another thing that makes this whole model really, really nice is this auto update based on the tag on your images. So this is something that's technically going to land as tech preview in this release. But if you're managing container lifecycles at your registry, which you should be doing, everybody should be doing that. And if you want to have a certain tag land on a certain set of boxes, maybe you're going to phase in or have all of them are going to pull the prod application. Basically, we can have timers on these nodes that now check that tag at whatever interval is appropriate and just kind of auto pull that image and update as new ones are made available on the registry. So again, little features like that make life super simple, and again, easy to scale because these are all client initiated actions. So it's nice. Okay, so let's talk a little bit about what we're getting in 8.3. So I mentioned Image Builder is kind of the front door of this tool. This is made available via the Cockpit UI. There's also a CLI and an API for this. But we really log in, and approximately 4 clicks, you're going to get the default image. If you need to customize it with RPM content, you can. Here I'm going to include crun, as I really enjoy crun because I like using Secrets v2. It's super fast to instantiate containers as well. But here we'll go ahead and we'll commit this to the blueprint. Again, you don't have to do this. By default, we'll give you everything you see here listed on the slide, a small at core install with our container tools, as well as some goodies that we'll look at in the next couple slides. But you see, I just select the image content, RHEL for Edge, commit, and this is going to generate an RPM OS3 commit that we can then serve out from a central place. And just, again, this is going to give us that remote update capability. And that's it. It's going to kick off the build right here. We can see this going. And it happens pretty quick. On my junky laptop, this will complete in, I don't know, 7-8 minutes. If you're running on good hardware, expect faster results. All right. So let's talk about the mirroring and providing these updates. So again, we create the initial image the way you saw. We are going to create updates for these images using that same process. So it's one thing you have to understand, that you are now driving these boxes and you're driving that update cadence, and how, like, you have fine-grained control over everything that happens on these systems. And again, once these updates are created, we can put them on any type of web server. So if you want to just Apache box or host a container somewhere, if you're going big on a prod environment, please use a CDN of some type, just depending on what type of load and number of nodes you have. And then these last two, we've kind of itemized a couple of the configs on your systems that are going to control where they're looking for this web endpoint. And then the last one is one of my favorite things, where we can, if a new update is published, we will automatically pull that down on the nodes. And I'll pick that up in a couple slides on how we actually take the update and accept it, but it's super easy to stage these updates locally on the systems. Okay, so let's take a look. I am using the terminal on the web console, and I wrote a little script so I wouldn't fat finger things for everybody. But if I check the status of that image build, I can see node 0 is finished here. And this compose image is really just going to download it and give me an artifact that I can work with here. And this happens super fast since it's local. But I now have this tar file with that commit of the RPM-OS3 locally. And now I'm going to build a web-based server to host my commit. So I'll spit out the file here. You can see it's super simple. I just give me Apache, extract this tarball that I made in Image Builder, and then go ahead and serve that. So no magic at all is needed here. So just go ahead and build that image. It's going to happen quickly because it was already built on this node. And then I'm just going to bind it to port 8000, so I can run this particular one as rootless. There's no requirement to do that again, but this is a good proof point that you can host these any number of ways you want. And then once that's going, I'm just going to curl the latest ref of the commit. If you guys have used RPM-OS3 or looked at it, you'll know that it's kind of modeled after Git. So a lot of those same ideas and concepts that you probably are familiar with from Git, RPM-OS3 basically leverages those. All right, so once you have made an image from Image Builder, that is a good way you can easily serve that up. And let's talk about the updates themselves. So day one is pretty simple. Updates, though, a lot of edge environments, some of them have like amazing data center style networks, which is super fast, and efficiency at this tier is not, it's a nice to have, but it's maybe not a requirement. But in some environments, we have just horrible connectivity, like microwave links that make modems look really, or old dial-up modems look really fast. Retail, we still see like fractional T1s and these types of things. And so what's cool is, even if you have constrained networking, this now makes it possible to update those devices, because it's much more efficient by only sending the delta of the update over the wire. If you generate what's called a static delta, you can actually pull it over like a much less TCP overhead, which is just great, and again increases that efficiency. But even if you have really great connectivity, and bandwidth isn't like near a scarce resource, you still probably want to be using that for your applications of workloads, not OS updates and these types of things. So having that efficiency really helps regardless of what type of infrastructure you have. And again, this is just a great side effect of using rpm-ostree natively for all this stuff. Now provisioning here. If you're familiar with RCOS, you may be wondering, why is this not ignition? Well, we're looking at ignition, and we may include that in the future as an option. We're certainly open to that. But right now, a lot of these devices have we just see this gamut of hardware that has all these weird requirements, and so Anaconda works incredibly well to fit this rpm-ostree commit onto those systems. So Anaconda is just makes this really easy today. And so this little example just has a kind of a bare bones top section, and then really instead of having a percent packages where you would normally list out all the content to install, we're just going to use rpm-ostree commit, and we're going to point it to your mirror. If you point it to your production mirror, once you deploy the system, it's going to know where to look for updates automatically. So that's probably a good thing to do if you can. And that's all you need to do. You can do any customization stuff in %post if needed. Pre is still there. But kind of a good rule is to keep these as simple as possible. Okay, and so that's how we can easily just get the commit onto your devices. And now a little bit about rpm-ostree. It just really gives us this great kind of the best of both worlds. If you think of a traditional like embedded type firmware, like your router that may have an A and B partition on it. So we kind of blend that A/B update model with like the benefits of a package-based distribution. So it's nice. So if we ever need to make a change to what's on a system, because one of the key things here is to be able to adjust for change that happens in your environment over time. And so this model is super easy to adapt over time, which is really powerful. So again, we get the benefits of this A/B model where we can fail back if necessary, as well as kind of that flexibility with the packages, which is great. So really everything of the operating system that lands under /user gets swapped out with or at least in each commit, there's the full OS in there, right? And then once you pull that into your repo and clone it locally, again, we're only going to send the delta, but you get that full commit locally where you can go to either state of the device. We do maintain state in /var and etc. So the whole operating system is not technically immutable, like from the strictest definition possible. And that's not a bad thing because true immutability often requires a significant amount of infrastructure to be available. And that's not something that we can count on in these environments. So again, maintaining your configs and container images and these types of things is generally a really healthy and convenient thing to do. So that's it. And we always get this known state that we're operating in on the system, which is powerful. So I mentioned earlier that we can automatically stage these updates in the background. And so that's a great way to approach it. That's probably what I would do, but it depends on your environment on what you should do. And then whenever an update is staged, typically you may want to align to a maintenance window. Again, a lot of these systems are responsible for like critical infrastructure and can't just accept reboots, like free form, like we would expect in a cloud environment. And so it's pretty easy to schedule reboots with a timer, or there's a number of ways you can use any type of a management system. But once you have a scheduled reboot, when they come back up, they'll be at the next update automatically. So that's how that works. So updates will cost you a reboot. However, as long as you time that, typically accepting a reboot should be less disruption or potential unknown disruption than updating a live running system and making changes on the fly. This is a really good model. Okay, so last little screenshot is just to kind of give you guys a look. If you haven't played with rpm-ostree on a system before, I'm going to SSH into, this is a bare metal system I'm running. And again, I'm using the web console terminal to do this. I'm running a container that's just sucking the 4 cores of this little box dry. and I check the status. I'm running a single commit. So this box has just been provisioned from Image Builder. That is the commit of the update. And I'm manually triggering an update because I don't want to wait for the timer to do it automatically for me. And this particular one just pulled in, new kind of the container tools packages have been rebuilt for this one. And we can see when I check the status that I have a new deployment here that is staged and not running on the system. And of course, my workload has not been interrupted at all. It's still going. Now I'm forcing a reboot just to move into this really quickly. You can see how I got impatient and tried to SSH before the system came back. And I checked the container runtime, and of course my application is running as expected because it is being managed by systemd. And we can see here the asterisk has moved up, and I'm in my new update. Now again, this model is familiar if you've been using like things like Atomic Host in the past, or maybe Silverblue and Fedora. RHEL CoreOS does use this model as well. So hopefully this makes sense to everybody. Now, this last thing is kind of what's new and unique to what we have in RHEL. Basically, this technology is Greenboot, and it's the first time that I'm aware of where we can have custom health checks for applications running on the system. So let's say my node has like 3 critical things it needs to do. I can basically write scripts, and Greenboot gives us this framework to run those scripts that integrates with the boot process of the system. And if they fail using a counter system, so it's not strictly like, well, it's as flexible as you need it to be. If an update causes one of the critical roles of that node to fail, we can revert the state of the system and go back to where it was working, right? So super powerful here. And we're basically really excited to have that linkage again between the workloads and the operating system update level. One of the customers we worked on this capability really closely with, their feedback to us is basically the combination of RPM-OS3 and Greenboot is going to save us millions of dollars with our deployments. Once these systems get provisioned at the edge, the goal is to not go back and revisit them physically. And so you can imagine how having this type of safety mechanism in place is a big deal for a lot of people and moving into this space. All right. So with that, basically, again, I mentioned 8.3 as kind of the first step in our journey of kind of meeting the challenges of this space. We do see the security story of RHEL being a huge value to edge deployments. In fact, that challenges we talked about earlier in this talk, I would say all of those challenges kind of live on top of the security concern, right? Because again, in the data center, things tend to be physically protected. We have cages, we have badges systems, and you may or may not have any of that for the edge. And so being able to promise that same level of security without physical protection is huge. And so RHEL has a huge value proposition there today, and one that's going to get even better in the future. And the other thing around edge in general is we see complexity as being a huge challenge for really any IT project in general. And we see Edge, or RHEL in particular, it's solving a lot of the complexities in this space. And so hopefully kind of the little example in these features we brought through in 8.3, hopefully you can kind of see that, if I need to put these applications that's relatively static on some smaller devices, maybe they're big servers, it doesn't really matter, and just keep these, maintain them steady state, make sure they're updated. This is a super simple way to just go meet that need and be successful. And then of course, why not do that by leveraging kind of the existing investments in people skills and technologies, right? That people know and love from Red Hat. So that's a key value prop in everything here. And so at this point, I guess everybody's probably going crazy thinking, oh my gosh, I've got to get my hands on this and try it to go conquer conquer edge in my environment. And so, one, you've come to the right conclusion. And two, it's super easy to go do this and get your hands on it. If you go to the OS build GitHub repo, we really have kind of this whole thing documented out here, and you can walk through it. It's super simple. You could just do it in a couple of VMs if you like. Really, however it makes sense, but it's it'll take you anywhere from 20 to 40 minutes depending on your setup. Super simple, and of course, we'd love to get feedback from you guys, hear what you think. And again, this will GA pretty soon when 8.3 hits the streets, and we will update this demo to reflect that. And with that, I guess that's our look at how we are adapting Red Hat Enterprise Linux for the edge, and I appreciate everybody's time and being here. Ciao.
Thank you. That was like awesome. And I know thank everybody for remaining quiet so I could get that great copy of the demo and everything else. So I will unmute folks if you would like to ask any questions. And you did tell us about how to get started. So that's always my first question is where to go to get started and do that. But I also am curious because I work as one of the co-chairs for the OKD working group. And we're using Fedora CoreOS and talking, back and forth with folks like Peter Robinson on the Fedora IoT, and we use Ignition,
Yeah.
For the OKD4 release. And I'm not wondering if there's, I know you were talking about Anaconda, but if it is in the roadmap to eventually support Ignition.
All I can say is we're totally open to it and looking at it. I love Ignition, right? I mean, I run Fedora CoreOS here at home. It's awesome. So I don't know. There's kind of pros and cons on technology you use for config at day one. So there's a lot to like about Ignition, but it's not necessarily a slam dunk. I think what would be the best of all worlds is if we could give people the choice of Ignition or Anaconda would probably be even better, because then, people that have these, I need this weird RAID thing and all this complex stuff. It's actually super simple to do in Anaconda. Whereas Ignition, we kind of have to like copy the OS to memory, then scramble your disk, then write out from memory back onto disk. And, again, we need that failure domain to be just like non-existent when I can't visit systems. So that's personally what I would like to see. I don't know. I think that's probably going to shake out over the next few months, that plan. But yeah, so sorry I don't have anything solid there, but
That was the only
thoughts.
surprise for me, I think,
Yeah.
in the talk, and listening to you was that. I mean, I'm thrilled, and I'm not going to ask you for, when is the 8.3 release going to land, because I think that's one of those, we're now a publicly traded company, we can't disclose those kinds of things, or I'll get shot by an engineer. But I'm hoping that's relatively soon, because we've had a lot of conversations with people trying to shapeshift like OKD4 for edge use cases.
Yeah.
And that conversation about, well, you should be looking at Fedora IoT, or now RHEL on the edge here. Do you have a product or a projecty name for it yet? What you're doing here?
Oh yeah, great. I should have put that in the presentation, but like a lot of this technology and ideas come out of the Fedora IoT space. So the Greenboot comes out of that. Peter Robinson, is really one of our guys that drove a lot of that. The difference though in how we chose to productize this though was, rather than make a kind of a pre-existing artifact like we do on the CoreOS side, was we wanted it to be composable, because we, again, in this space, we know the range and breadth of needs is huge, and so we didn't want it. If you have a pretty cookie cutter environment, you know what you need to go solve. You know what? RCOS and OpenShift is awesome, particularly if you need the capabilities of the Kube API, right? And you need dynamically deploy stuff. Everything's super powerful, and it's a great fit. Obviously, Edge is a huge focus for us on that side as well. But even with that, there's still like this kind of those use cases I rattled off on one of those slides where as powerful as Kube is, it's probably not going to replace all of Linux, right? It's not good for all the things that Linux can do. And so I think those are some things where, we're really just kind of turning the knobs of what you can do with an OS will meet those needs really well.
Yeah, I think there's, well, this is Diane's opinion, not Red Hat's or anybody else's, but there's this wishful thinking for Kube on the edge. Like let's
Yeah,
have a succinct solution, and then I get all the functionality of Kubernetes on the edge, and then you go through the trouble of trying to do even just a single cluster install of Kube, and you're like mind blown at how much that is just for Kube, and then OpenShift has all of its value added stuff and the operators that you need, and mind blown again, how big it is. And when you really start thinking about edge and how small some of these devices are, um, having enough memory to run that. So the value, there's a lot of value propositions in RHEL, but like projects like Podman are huge. It help
yeah,
us to make us be able to deploy and be efficient in this space. So, there's it's always interesting how people think, like associate like cloud native with Kubernetes, but it's all these ancillary projects as well that are the helper apps that actually make things work, and potentially change our lives and change where we can do innovation. So it'll be really wonderful to see in the next release what people do with these with their use cases and as they bring them forward. So where do you
I
want
agree.
people?
I
Oh, go
did.
ahead.
I did want to show you this. This was the little box I SSH to in that demo. And these are super cool. It's just a little 8 gig of memory. It's a tiny Atom processor, which all the atoms are on the support list for RHEL now, which is pretty cool. But these are not super expensive, and I don't know, they're just really cool with what you can do with them. So I don't know. I probably get most of my value from this and holding it up in web conferences so people get an idea of what we're talking
Yeah,
about.
it's pretty amazing how small some of these devices are getting. And someone came to the OKD working group with a retail outlet uh, story that they were trying use case that they were trying to deploy, and they were trying to get Kubernetes completely working in like with a camera processing all the AI and GPU and on it, and it's just amazing, like the how small and compressed all of this stuff is getting. But still, to get all that functionality is in that one little space is going to be an epic that we're still writing, I think, and that's going to take a bit of doing. So
Yeah. So I mean, I guess going back to your point a second ago, I think there's huge opportunity and value in this space for both. Like Linux and Kubernetes is going to be the de facto on it. So I think I don't know when I talk to customers today, it very much brings me back to like 2010 kind of time period when I joined Red Hat, and a lot of the customer conversations were people trying to wrap their heads around like cloud and what's possible there. And most of the calls were like this, like people were dreaming of these things, right? So today when we look at Edge with this like technology landscape we have now, it really reminds me of that same time. Like all the conversations are like this like dreaming of what's possible again, which is really cool and exciting for me. But I don't know. It's just an interesting parallel that I think we see with like the maturity and stuff. And we've of course learned a lot of lessons over the past 10 years. I'm sure to some degree we'll repeat all the same mistakes, but hopefully we'll be a little smarter. But yeah, it's a good time.
yeah, well, the wonderful thing is we're doing it all in the open, right? So it's
Yeah,
like, all right, we're going to repeat all these mistakes, but you'll tell us, trust us, you'll tell us where it doesn't work and everything. So, um, really thank you for taking the time today to do this. I'm not seeing a ton of questions here. I think people are off now in Fantasyland, just trying to figure out what they're going to do and how they're going to test that build on the edge demo of yours. So I think that's going to be great, and really appreciate you coming today. Is there any place that you want to point people to besides that demo, if they want to reach out to you, or is there like I don't know, IRC or Slack or someplace where they should get a hold of you if they have a use case?
Yeah, I'll just drop my email in the chat.
Okay.
It does not come with an SLA, so I have a long backlog of email, but I guess hit me up if you guys have questions or ideas or have feedback. We'd love to get it. I think at some point we probably need to beef up like a community path here. I don't.
Yeah.
Peter would probably give you a better answer than my
Yeah, I was
email,
just going to say
but for
that.
now, let's do that, and I'll have a
Yeah.
better answer next time.
I think it's interesting because I think we probably I think we have or someone has asked me to boot up a SIG in OpenShift Commons for just Edge stuff,
Hmm.
but it's been such until we got to the point that you've been describing today. There was it was a lot of slideware
Yeah.
and internal POCs and customer POCs and a lot of conversations in Fedora IoT. So I think maybe now we have like a center of gravity for doing something maybe on a monthly cadence or at least create a community landing page for people to reach out and share their use cases. Because I know, yeah, a few people, they keep showing up at OKD working groups or Fedora CoreOS ones, and Peter's really been doing very good stuff. So maybe we can do something to make that happen in a not too distant future. Because, now that everything's virtual, we can wake people up in the UK really early in the morning. Um, as we are wont to do. This morning I was up at 4:45 to record at AM to record somebody's talk. So I'm like, if I can get up that early, we can get Peter up. So
Yes. Oh
yeah,
man, there's yeah, time zones. I still dream of a world where we all operate in UTC, but I don't know if that's going to happen.
oh, if only the sun would oblige and come out at the
Yeah.
right time for that all of that to happen. It's like, yeah, today was recording stuff. Open Source Summit in EU happened this morning, and booted up, and yeah, it's crazy, and it's really interesting to see people as we evolve on how we use these virtual platforms too. What kind of interactivity we can do, and I still haven't seen really great like hackathons online or
Yeah.
virtual hands-on workshops. Especially now with Edge too, it's like now you have to have the hardware. So what are you going to do? Ship the hardware to someone's house? Like a virtual swag bag with that CompuLab fillet in it, and which would be an awesome swag bag, by the
That
way.
would be.
We would all love that. So that would be really, really cool. So thanks again for taking the time to do this. We will be rehashing this at the OpenShift Commons gathering on demand, and we'll probably ping Ben to join us there too to answer any questions. So look forward to that on November 17th at the OpenShift Commons gathering on day 0 of KubeCon, along with like 20 other day 0 events. But yeah, it's gonna be crazy that week. There's gonna be a lot
Day
to.
zero events are way better than day zero security problems. So
Yeah,
way better.
that's true. The new thing that I'm doing now is I'm encouraging people to binge watch this stuff
Oh,
as
nice.
opposed to watching it live on the day of. Because I think binge watching an event like Open Source Summit or KubeCon is probably going to be more realistic than being able to get the whole day off from work. That's the other catch with virtual is that when you could go to a conference, you couldn't physically really work. Well, you shouldn't. You were
Right,
there.
right.
Now there's like, oh well, I'm still coding here, and I still got to do this deploy over here, and but I've got you on the screen over here, and it's not the concentrated and focused educational fire hose that events in person more. So I think the new model, I think for virtual events is really getting people to have the available data and content online so that they can binge watch it instead of Black Mirror or something else.
Right, because at, every time I watch Black Mirror, I hate myself afterwards. Um, so
Well,
I like value added content that like you said is educational and adds again
yeah.
is real value. I mean, I get it's not zoning out to Tiger King, but man, what a better way to spend your evenings.
Yep, is binge watching RHEL on the Edge. That's I think that would be great. The
Of
one
course,
thing
God,
about
I'd rather watch Tiger King than listen to my monotone voice. So maybe I'm a hypocrite.
it's surprising because always with the YouTube stuff, it's always the long tail people watching stuff. But the other thing on Friday, we did a talk with Fabio Pereira, who wrote a book called The Digital Nudge, and it was great. And he used one example, which is why I have the Netflix binging on my, is that like Tiger King or there, it doesn't ask you if you want to view the next thing. It just goes to the next episode, and so
Yeah.
you like you don't even have to opt in. You'd have to opt out to watching the next OpenShift Commons gathering
Yeah.
talk. So I'm thinking Netflix is my new business model here for Commons content. So we'll see if I can get Netflix to agree with me. So anyways, thanks again for taking the
Yeah.
time today, and we'll let you go. And if you can send me the slides, I'll make sure those go out too.
Absolutely. Thanks for having me, and cheers, everybody.
Take care, guys.
Bye.